Okay, hi, I'm Tatiana Shubin, and my co-presenter, Henry Fowler, could not come. So I apologize, and I will be the only presenter here. But we did it together with him, and it's too bad that he's not here. So this is about Navajo Nation math circles. Last semester, well, not last, it's already one semester prior to that, in the fall semester of 2012, I took sabbatical leave, and I went to the big Navajo reservation, and with the goal of studying math circles there. Math circles have been around in Eastern Europe for about 150 years, and for more than 20 years, or close to 20 years, in this country. And when this movement of math circles movement started about 20 years ago, or even 15 years ago, people, when you would mention math circles, people wouldn't understand what you're talking about. You would have to explain. Not anymore. Mostly when you go to a mathematician or to math teacher at school, and you mention math circles, they have heard the term. They don't, no longer they need to be explained that. But when I came to the Navajo Nation, that was different. They had no idea what that whole thing was, and it took some time to persuade them that it's something that they might try to, they can let me try on their behalf. And eventually they got persuaded, and it started, and I was actually very, very fortunate to be able to start 5 circles for kids and 1 for teachers. So let me just show you some things. Oh yeah, I was supposed to say ya'ate, it's hello in my native language, in Navajo. Because when I was there, I got adopted by a Navajo family. So it's now my language. Not that I know lots of words in it. And this is our project's logo. We also ran a competition among kids in several different schools. We asked them to produce a logo, and there were only 2 conditions for that logo. It had to combine the idea of math circles with the idea of, with the Navajo culture. So in the middle, and this is the winner. So this is now our official logo, and it's a winning logo, produced by a girl in one of the schools. And in the middle, the image in the middle is the traditional Navajo wedding basket, except for pie. Pie is not traditionally there. And the 4 mountains around are 4 sacred mountains of the Navajo Nation, which signify the 4 cardinal directions. They are very important. And the girl thought that putting on each of the mountains one of the 4 cardinal signs of mathematics would be very appropriate. And for that girl, those plus, minus, division sign and multiplication were the cardinal signs of mathematics. And of course, on top, it says Navajo Nation Math Circles Project, and at the bottom, it says the same thing in Navajo. In case you wonder what Navajo Nation, where Navajo Nation is, here's a map. So in the right top corner is the picture of the 4 corner states, and that pink part is enlarged, and that pink part is the Big Navajo Reservation. The size of it is about the size of West Virginia, so it's huge. Well, these are the 4 circles that I started and ran for the whole fall semester. 2 were in the same school, St. Michael's Indian School, but they were completely separate circles. One was for high school kids. Some of the kids who went to high school kids circle were actually in the middle school, but they were advanced. And then there was another one for middle schoolers. Then one was in high school in Chinle, one was in Sehatsoy School, and one was in Many Farms High School. So 2 were for middle schoolers, 3 were for high schoolers. And here's another map which can you can, well, probably you can't really see. Let me try to show you. So this is Fort Defiance. This is Window Rock right here. Window Rock is the capital of the Navajo Nation. And St. Michael's School is right about there. Fort Defiance, where Sehotsui School is nearby. Then Chinle High School is right here. And it's about 50-mile distance from those two places. And Many Farms is even up north from Chinle. Okay, now this is a picture of the road leading to St. Michael's High School. It's pretty isolated place. And these are the kids in the high school. This is high school circle. They're trying to solve a problem how if you have 17 cups that are upside down, and at every turn, a person is to flip a cup 10 times. Well, they can be different cups or one cup, it doesn't matter, but just make 10 flips. The goal is to have them all upright. Can you do that? And they're pretty involved in doing that and trying to solve that. And this is their middle school. And you can see that kids are pretty much involved. Now, middle school was a difficult thing. When I just started middle school circle, kids had about 10-second attention span. And that was it. It was not possible to do more than that. But then, the good news was that after the 2 meetings, and we had 2-hour meetings, by the 3rd meeting, it completely changed. They were able to stay on task, they were able to be focused, they were able to really enjoy what they were doing for a long, long time. And it repeated in both middle schools, the same thing. And teachers were really surprised. They said, well, what kind of magic do you do? No magic, it's just nice problems. Okay, so here are the sessions that I actually ran in middle school, and we met once a week for 2 hours, and these were the hour meetings. Now, all of these topics are more or less, everybody can understand and know what they are, right? The one thing that I wanted to show you what we really did is this triangles, squares, pyramids, and cubes. There were lots of problems there. We start with the very first problem which took them a while, and they actually didn't want to let go. I wanted to push them to something else because I had some idea that it might be more interesting, but no, they just wanted to stay there. So you have four states that are, each state is in the shape of a triangle, and you need to position those states so that every of those triangular state has a piece of a border shared with 3 others. And so that is kind of a puzzle, but they really wanted to do it, and they really wouldn't let me move anywhere. I think that none of them actually solved it, but they were getting close, and they were getting all sorts of interesting things, and they were just thinking of what they were doing. And then we had lots of other problems, and don't get me wrong, this is just the list of problems that I had with me, but we never, ever did all the problems that I had on my list. But I would give them, at the end, I would give them those lists, and I would tell them, look, if you are interested in any one of those problems that we never got to, go for them. And if we want to discuss them next time, we will start with that. If not, you can just think of them as long as you wish. And some more. Okay. If you are interested in any of these, I will be happy to give you all the handouts that I have. Just email me. Now, in the high school sessions, we did more or less the same, but on probably slightly different level. And then I added some more topics there. Now, what are our next steps for what we are planning? Well, first of all, one of these next steps has already been taken. In April, in April, Amanda went to visit, and she ran several sessions for kids in schools, and she also ran workshops for teachers. She ran a couple of workshops. One was specifically for math teacher circle, at math teacher circle style, and another was on relation with Common Core. And then we are planning to have summer math camp, for 2 weeks in July. And in the middle of those 2 weeks, we are going to have workshop for teachers. Now, the thing is that a usual and standard and, well, respected and tested model for a math circle is it's an enrichment form of math enrichment where mathematicians or mathematical scientists get directly with the kids or with the teachers. Now, this model cannot work on the reservation because of the distances. The two closest universities are North Arizona University on the one side and New Mexico University and Albuquerque on the other side. And both are about 200 miles away from the middle of the reservation. So we cannot expect people come every week for, like mathematicians coming every week from that distance to run a circle or circles. So the idea is that every circle is to be led by a teacher. And also because of the distances involved and transportation problems, instead of running it somewhere, some central circle where kids can come from different schools, they have to be run at a school. So this is why it is so important to have all these, different circles in different schools, because that's the only way for kids to really be able to attend them. And this is why it is so important to run all these workshops for teachers. And these workshops, these math teacher circles are different in a sense, because we really and specifically want to try and involve teachers who want to start and run their circles for kids in their schools. So they're slightly different, and not just for the enjoyment of the teachers, but for that, with that specific idea in mind. And we also want to help those, well, we have, as a community of mathematicians, we really have to support those circles. Teachers, regardless of how nice, how great a teacher they are not mathematicians. We need to help them to choose good problems. We need to choose problems that are not just interesting, but that lead somewhere deep in mathematics. That's our role. So what we want to supply teachers with what I call scripts. Those are not really scripts in IBL meaning and OS, but a list of nice problems with some discussion, some more or less detailed explanation to the teacher, explaining how they can, what way they can go. And there are several ways always. And if you go that way, what happens? If you go that way, what happens? And also, which is very, very, very important, explaining what is mathematics behind it, why that set of problems was put together. It's always done because we really want to have some sort of interesting and deep mathematics behind it. So this is one thing that we really, as a community, we need to do to help those teachers. But it is also very important to keep visiting them. So that the idea is that once a month, some of us, goes out there and spends some time and leads as many circles as possible and communicates with all these teachers and with all these kids. And Amanda has already started that. Harold is going to do it next fall. And if any one of you might be interested in doing that, please let me know. It's just absolutely great to have people who are involved. The more, the better. Now, at our... Yeah, it's time. Thank you. Thank you. This is our camp. And what I really want to show you, we are going to have two distinguished visitors at our camp. we will have, every day we will have 2 math sessions, very deep and difficult, challenging sessions, except for Fridays. On Fridays, we will have 1 session only, and in the afternoon, we will have distinguished speakers. One with Bob Megginson, you probably know him. He is a mathematician, he is a math professor and dean at University of Michigan in Ann Arbor, but he is also one of about 12 Native American math PhDs, which is a shame. Just 12. And this is one of the things that math circles might help to change. And another distinguished speaker is Commander John Harrington, who is the very first Native American astronaut. And both of these 2 people agreed to come, and they will be great role models for our kids. And just the scenery is breathtaking. I highly recommend come to there. You will enjoy it in all respects, in absolutely all respects. Okay, thank you very much.
You spoke about the refocusing of the students, where they started off in the first 2 sessions where they could only keep focus for 10 seconds at a time. And after those first 2 initial sessions, that their focus was much better. Was there any direction whatsoever, behavioral direction, given by the instructors or you, or did this just happen from the content engagement?
It just happens. Actually what did happen was that at least in one school, not in both schools, but in one school, at the second session, not in the first. First session, we had like 8 kids, and it was manageable. Second session, we had about 15. And when all these 15 kids started just running around and doing their stuff instead of doing what I want them to do. And I was alone with them. There was no teacher present. So I was just there. And they didn't know me. And so after a while, I got really very impatient, and I said, okay, let's do it this way. If you want to do this problem, if you want to talk about this problem, if you want to try and solve, and if you want to participate in circles, fine, we'll do it. If you don't, just be in that part of the classroom. Just don't interfere with us. I don't know, it probably was rude, but it worked. Those kids there were several kids who just went to the other part of the room, and then, one by one, they were trickling back. And they tried to do it so that, nobody notices. But most of them came back, and then next time it was better. But I think that it is, that happened in one school. In another school, I didn't have to do anything drastic like that. Just somehow it works. I believe that they get the feel of, it's interesting to just try and solve this problem, to struggle with that problem. They had never seen anything like that. They had never been challenged to problems where they really need to struggle and stay with the problem for a long time.
Was it the older kids who were less motivated? Because the younger kids would seem to have a natural curiosity. Or, on the other hand, was it that certain schools had mostly students that were less curious?
Well, this situation with very bad attention span happened in middle school. I had middle schools and high schools. In high schools, I never had anything like that. Maybe they were somehow taught that they have to be, pretend to do things. It's actually very hard for them to pretend because there were not so many of them. And I knew what they were doing, and everybody else knew what they were doing. So that was not that much of a pretense. They really were doing that. And they were better trained. Probably by the time they get to high school, they become more trained to do things somehow on their own. But of course, there is also a big difference between different schools. One of the schools where I had 2 circles, this is a private school. It's run by nuns. It's the oldest school for Indian kids in the country, and it's more than 100 years old. And they have their traditions, they have their expectations, and kids are very, very polite and very interested in what they're doing. In other schools, in public schools, it's not. Kids are still polite, but not to that extent, and they're not as motivated as kids in this private school. But there was a big variation between kids in the same school. Some were much better prepared than others. Well, what I have to say is that I didn't see much difference between these kids and the kids in my own circle that I've been running at San Jose State and in the middle of Silicon Valley, and all the parents pushed them very hard and harder than that. As far as curiosity goes, and just the willingness to learn things and go into depth of things, I didn't see much difference, but there was a tremendous difference in their preparation and the level and their skills. These kids, even the best of them, even in the best school, didn't know lots of things that I would expected them to know. So while working with them, it's very important not to go into any technical things, at least in the beginning. Eventually, they might see the necessity of developing some tools and some technical things, because it's just the problem that requires that. But to begin with, something that, like draw those 3 triangles. Everybody, oh no, not everybody can draw a triangle. I just learned that in middle school, that was for middle school, lots of kids had no idea what a triangle is. And they could not draw, even if maybe they knew it, but they had no idea what a straight line is. And when they were trying to draw it, it had absolutely nothing to do with straight lines. Oh, I have 15 more minutes. Great. Okay, so actually, the reason I'm asking is the following. We did ask for some format, and the organizing committee at first told us, well, you do whatever you want. You design your session in whatever way you want. And so we designed it in one way, and then eventually, then they told us, no, you have to design it so it is compatible with other sessions. And because of that, I'm not so sure what to do for the next 15 minutes, except that I did because of that requirement, I was thinking about splitting it into 2 talks. One mostly geared for student circle, and the other half geared for teacher circle. So if you are still interested, I can talk a little bit about teacher circle that we had there. But I need to get out of this one and to my other. And in the beginning, it will have exactly the same slides, so I will not do those same slides, but there are some others. Yeah, so this is slightly different because it's, I list all those circles plus Math Teachers Circle style course at Diné College. Henry Fowler is a teacher at Diné College. He is a real Navajo. He grew up on the reservation. When he was 7 years old, he was in charge of taking family sheep, like 200 of them, taking them to some place to graze. And he was very good at counting sheep. When he at the end of the day, he would come back, and his mom would ask him to count the sheep, that he didn't forget any of the sheep. And he invented a way to do it efficiently when he was like 7 years old. He broke them into some little parts and counted counting them in one part, and eventually he just developed multiplication because he didn't want to count them all over again in different parts. His mom doesn't speak any language but Navajo, and Henry, when he was growing up, didn't speak anything but Navajo. Well, his passion is mathematics, and mathematics for the Navajo kids, and he really believes that if more Navajo kids are exposed to more and more meaningful mathematics, it would make a huge difference in their lives. So now he has a doctorate degree in ethnomathematics, and he teaches future teachers at Diné College. Diné College is the oldest tribally owned and operated college in the country. And it is a 2-year college, but they have one program that is a 4-year program, and that is teacher preparation program. And Henry works for that program. He taught, in last fall, he taught 2 courses for future teachers, and he allowed me to take half of one of those 2 courses and just do it my way. So the course met in Diné College for 2 times a week. One day of those two days, Henry would do his stuff, and the other day I would do whatever I wanted. And I just ran it as a math teacher circle. Those people most of them were pre-service teachers. Some of them were part-time teaching at the time. But so I just threw at them lots of problems, and they were working on the problems and struggling with the problems and asking questions. And it really was like math teacher circle. Except that at the end of semester, when it came to close to the exams, they started complaining. They started saying, look, what you are doing is very interesting, and we enjoyed it a lot, but now we have this exam coming up. And, is it okay if we don't have the last meeting of the semester, and instead Henry gives us a review of the course? But that was the only complaint we had. And then, okay, that's the same thing. Oh yeah, this is the Diné College. This is a remarkable structure. It is 6 stories high, and it is in the shape of a traditional hogan, and it is in the middle of absolutely nowhere. Especially if you come from there are different ways to come to it, and especially from one side, when you come from one side, for miles and miles, tens of miles around, there is absolutely nothing. Just beautiful scenery and forest and mountains, and all of a sudden you see the structure. It's like out of this planet. Yeah.
Is it a hexagon?
I'm not sure, because traditional hogan can be anything, 6, 7, or 8 sides. Maybe this is 8. I believe it's 8, but I'm not 100% sure. Dana, did you count? Yeah, okay, so it's 8.
But it's not 5, so they don't
No.
call it the Pentagon.
Oh, no, definitely not. So this is where we are going to have our math camp. It will be non-residential, but kids will be brought there at 8 o'clock every morning and dismissed at 4 o'clock every morning, every afternoon. Well, these are the sessions that I did for teachers, and they are mostly the same things, but again, they're done in a slightly different way. And this is what I did for parity and invariance, and some of you might recognize this problem. It's about mad veterinarian. And
when I went there in April, they told me Corvina Etzedy was the teacher at Many Farms High School who gathered the kids for my sessions, and was also there in the fall. And what she told the kids that were new was that the amazing thing about a math circle is that it could start with anything, and then suddenly go off and you never know what you're going to end up visiting during the math circle session. So.
Okay, so we also, on top of having that regular meetings with that pre-service class, we, as I already mentioned, we had one workshop for in-service math teachers. And it was, I ran one in December 1st. There were 10 teachers, but there were more on waiting list, and they didn't make it because we decided that we wanted just 10, and Henry knew those people. He handpicked those people. Really, they were, we really wanted them to be some people who would benefit the most from this experience, and also who would be promising as future leaders of circles for kids. So this was special. They arrived at 9 o'clock, and it was December 1st. It was when they started to the place. It was also in Dana College. For many of them, it was like 50, 70-mile drive, and it was still kind of dark in the morning. And 2 people came a little late, like 10 minutes late. And they were a little upset because when they arrived, they were a little upset, but we already started. And then at the break, they told us what happened. They killed the horse. The animals are free-ranging animals everywhere there. So it is your responsibility as a driver not to hit an animal. And when it is dark, it happens even to these people who had spent all their lives on the reservation. They knew what was going on, but they just hit a horse and killed it. And then I talked with one of these people, and I was really, I was so upset myself, and I said, well, I'm so sorry. And he said, well, that's life. So I just took it as stride, I guess. But they were very, very involved, and they were very enthusiastic, and they really liked the experience. Well, then Amanda ran her own, and amazingly, there were like 24 teachers, right? And they were, Henry was able to get all those 24 in almost no time, because Amanda just told him when she's coming, there was not, probably less than a month in advance. And so he got 24 teachers to attend, so they really wanted to. Well, and the next workshop for teachers will be July 20th, and then we want to run a workshop like that every fall and every spring. So we are looking for volunteers, for people who want to go out there and experience all this interesting stuff and help people who really need our help. That's the workshop schedule that we are going to run in July. There will be 2. In July, it will be from 8 o'clock to 4 o'clock, whole day. And there will be 2 math sessions and 2 Common Core-related sessions. But Common Core-related sessions, you can see the names. They're still interesting problems. Amanda, is that so? Amanda will be running Common Core sessions.
I walked in a couple minutes late, so you may have already said this, but did you tell everyone that you were adopted by the Bitterwater?
Yes, okay. I can't avoid saying that. Oh yeah, what we're planning also is to attend ACES conference. Do you know what ACES is? It's American Indian Science and Engineering Society. It's a countrywide, and they have their annual conference at the end of October, beginning of November in Colorado, in Denver. And we want to present there, because the idea is that we really want to spread this kind of model through the Native American community. We started with the Navajo Nation for a number of reasons. One reason is that they are biggest and probably most prosperous tribe, and so we hope that if we can be successful there, then it would be easier to move it to some other tribes.
So I loved your problems. I've been being very attentive to the problem selection that you've made. So the 4 triangles problem,
Yep.
does that have to stay in the Euclidean plane?
Yes, it
Okay.
does. It does. Actually, I can give you another problem which is related, but it will be giving away too much. Are you interested in that? Start with a triangle, and then cyclically extend each side, make it twice as long, and do it cyclically. So now you have 3 points, right? Connect those 3 points, you have a triangle. The problem here is if the middle triangle has the area of 1, what's the area of the new triangle? Just extend it one side past the vertex, then extend the other one past the vertex, and extend the third one past the vertex, and do it in a cyclic fashion. And by the way, Henry actually told me after that session that I did, and he witnessed with the triangles, cubes, and stuff, he said that he believes that Navajo boys, because of their upbringing, because they were running around and with the cattle and with the sheep, they have, Henry believes, they have a better spatial perception than other kids, that they really are able to solve these problems. I cannot really just confirm that, because one of my problems was, if you have a triangle, can you cut it in 4 congruent ones? Surprisingly, most kids actually solve that one easily. Then the next question is, suppose that you have a tetrahedron. Can you do the same thing? And like you cut the top and cut the other 3 corners. What do you have inside? What's left? Is it another tetrahedron? And they couldn't tell. And I said, okay, go home and ask your parent to allow you to use 1 potato and make your tetrahedron, and then make your cuts and see what happens. Next time, they admitted that no one actually done that. Okay, we're done, I guess. Thank you, and hope to see you on the